All right. Hello, everyone. So my name is Walter, and I would like to introduce to IBH Help. Since I'm currently in year 11, I did not start IB yet, but I did have a look through the textbook, and I would like to explain to you what I have understood from it and teach you guys how to interpret the information. And so here I have made a table for myself, and then this is a chapter, and then this is all the information that I'll be going through. Today I'll be starting simple, starting from straight lines, but we will have set and Venn diagrams and a lot of stuff to go through, and then certain exponents, and then there will be a lot of stuff coming up soon, so hope you guys enjoy. Alright, so let's look at the point gradient form first of a straight line. So where do we plot straight lines? Well, generally we have learned of xy coordinates. So we have xy. I'm sorry if my lines are not straight, but we have something like this. And then we can plot a straight line by just drawing a line like this, or like this, or even something going like this. And yes, that's a lot of lines, but we will be talking through how to find the equation of every line if we know a few information about them. So let's look at the point gradient form. It says y minus y1 is equal to m of x minus x1. Okay, what is all of this? So x is a variable, so x is here and y is here. So it just shows that if x change, what value y would be. So for example, if x is here, then on this straight line here, this one, we will have y value of here, whatever value it may be. So a line shows a relation between y and x. What is x1 and y1? Well, let's look at the information behind it, where the line passes through x1 comma y1. So x1 comma y1, for example, this can be just a point where if we plug in x1, we will get y1. So then this will be called, this is a coordinate. So the x coordinate is x1, and then the y coordinate is the y1. And then we write it in the format x1 comma y1. All right, let me erase some of these graphs here. So we have this. All right, cool. So we know what y1 and x1 is. What is m? M is the gradient. According to the gradient is m. All right, what exactly is the gradient? Well, gradient is the steepness. So how steep a line is. It is generally defined by change in y, which we use the symbol delta, change in y, over change in x, which shows that how much y has changed depending on how much x has changed. So let's take an actual example, and let's say we use this line here, and let's say the points here were, let's say 4 comma, let's say 2, and then this point here is 0 comma, let's say -4. So we can see that y has changed a lot compared to just how much x has changed. In mathematical terms, well, we use let's say this is 2 comma 4, as we have talked about before, because of the x coordinate, y coordinate. And then this is 0 comma -4. So then how much has x increased from here to here, which is 2 minus 0, which is just 2. And then from here to here, y has increased from -4 to 4. So which is 4 minus -4. Which gives us 8/2, which means the gradient is 4. So it shows that the line is pretty steep because just one unit change of x gives us 4 increase in y. And then furthermore, we can also find the equation of this line, which we can plug in into this formula. Y minus y1 is equal to x minus equals to m of x minus x1. So if we find y minus y1, which is, let's say we use this set of points here, 2, 4, then the y1 would be 4. And then the gradient we found here is 4. And then we multiply that by x minus x1, which is 2 here. So this will be the point gradient form of this line here. Alright, so this will be our line. And then, so we have this. So hence that's the point gradient form, which is this first information here. So then what is the general form? The general form is just when you want to write like any line and you want to write about it, but you don't know any information. So how would you put it in the most simplest way? And if you did not know anything, what would we write about it? Like, we cannot find these numbers here. And we do not know what y1 or x1 or m is. So how do we find the equation of the line? That's basically the question that mathematician answered. So we have ax plus by is equal to d. A crucial thing to note about these is we want a and b and d to generally to not be fractions, and we want a to be positive. So we want a to be greater than 0, and then a and b and d to all be integer. So we have that. But what does this give? What does this tell us? Well, let's look at the general form again, where a, b, and d are all constants. What are constants? Well, x and y changes, so those are called variables. Variables spelled with V-A-R-I-A-B-L-E. A and B and D are something that does not change, which is why we call them constants, and it doesn't change whenever the variable change. So when we say, for example, let's say we give A the value of 2, B the value of 3, and D the value of, let's say, 4. Then we plug this in, 2x plus 3y is equal to 4, right? So, but then x and y is still not determined. It can still change. If x is 1, then well, y will have some other value, which in this case will be 2/3. Or when x is equal to 2, then y will be 0, and something like that. But whenever these numbers change, these values here, these constants, does not change. Yes, if we change this, the line will be different, but when x and y changes, the ABD itself doesn't change. It doesn't get affected by these variables, which is why we call them constants. But what does this have to do with the point gradient form of a straight line? Well, the point gradient form, let's say we use this line here, can be also turned into the general form. Because it's general, it's for every single straight line we talk about, even some bizarre ones or some general ones, we can always put it into the general form. And this general form is easier for us to compare these things. So let's try to put this into the general form. We expand this 4, so we have y minus 4 here is the same, and then y, I mean 1 minus 4 is equal to 4 times x, which gives us 4x, and then 4 times this is negative, and then times 2, so negative comes out, and then 4 times 2, which is 8, and then we want to put x and y on the same side here, so we subtract 4x to both sides, which gives us 4x plus y minus 4 is, this is negative 8 because the 4x has been subtracted, so it's on the other side. Now if we add 4 to both sides here, the 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 constant without variable, which is this d here, will be on the other side of all the variables, which gives us negative 4y, negative 4x plus y, add 4 to both sides, which is negative 4. But remember what we said, a must be positive. In order for a to be greater than 0 in this case, what should we do? Well, we can easily add 4x to both sides, which is another method for getting there. Y equals 4x minus 4. And then we add 4 to both sides. Y plus 4 is equal to 4x. And then we subtract y to both sides. So 4x minus y is equal to 4. This is a way to get there. But what if we just don't want to swap everything over? Well, we multiply both sides by negative 1, and let's see what happens. If we come down here, 4x, right? Negative times negative 4x, negative of y is equal to negative of negative 4, which gives us negative times negative, which is positive, so 4x, minus y. Negative times negative is positive again, and so that gives us 4. Look at these two. These two are exactly the same. Hence, we can multiply both sides by negative 1 in order to change a from negative to positive in order to get the general form. So we have the general form and we have the point gradient form. But what if you're not given a point, like specifically, but you are given the value? I mean, the easier way is that you have an xy coordinate. When you're given a gradient, when you're given a line, you generally look at like what points those two meet at like this y-axis and x-axis. So what if you know the gradient and you know one of these points or this point, which let's say, if it is, let's plug it into the point gradient form that we had here. So y minus y1 is equal to m of, let's say, m of x minus x1, right? That was our point gradient form, right? So then let's say we had this point. Let's say we call it, since x is 0, comma, let's say c. Then what do we get? We get y minus c is equal to m of x minus, since x1 is 0, this is 0. Y is therefore m of x, because, well, 0 disappears and then it's mx, and then we add c to both sides, which gives us mx plus c. So now it's very simple. You just need to know the gradient, and you just need to know what c, which is the y-intercept, is. What if we had this point instead? Let's say we call this c comma 0. Let's say a comma 0 instead. Let's plug it into this formula again. Now this time y1 is equal to 0. Y is equal to m of x minus a, which is mx minus am. Well, this doesn't really tell us much, because even though we do know the x coordinate, we also need to find the gradient and multiply them together and then negative it. It's much more simple to use the y-intercept to find this instead of the x coordinate. But if you are given the x-intercept, you can actually plug it into this formula and find the line. And guess what? This is actually one of the forms that we learn, which is called the gradient-intercept form, which is equal to y plus mx plus c, which m is the gradient, and the y-intercept is c. And this is exactly the formula that we get. So again, y-intercept is where the line meets the y-axis, and then the x-intercept is where the line meets the x-axis. But it's much more convenient to use the y-intercept instead. Note that c can be anywhere from here to here, or even up here. But no matter where it is, we can still use this formula to figure out what the equation of the line is. Alright, we have all of that. So we know how to express the straight lines into several forms. So how about we are actually given a line? So for example, let's say y equals to 2x minus 1. And let's say we actually want to plot this onto a graph instead of having a graph giving us the straight line. How would we draw this is the question. Well, we generally, a line is defined by 2 points. If we have 2 points, we can actually draw a straight line through them. Well, that's not the best line, but let's assume that, yeah, these 2 points here, and then this is the line. If we have another point in the line, then, well, it does help us further define it, but 2 points are more than enough. So, in order to plot a straight line onto a coordinate plane, we do exactly the same. We generally look for integer values, so for x and y. So if we plug in x as 0, we get -1. So we know that it passes through this point called 0, comma -1, which, by the way, this 0, where x is 0 and y is 0, is called the origin. So it's 0, comma -1, which is this point. And let's say we have, let's plug, let's say 1 into x. Then, well, when x is 1, so 2 times 1 is 2, and then 2 minus 1 is 1. So it's 1, comma 1. So let's say that point is here, 1, comma 1. Then if we draw a straight line through this, which my line might not be as good as I think, something like that, let's assume that's a straight line, then that will be the line. No matter however more coordinates you like add, it will still be on this line that we have just created. Let's say if we say 2 comma 3, it'll be 2 comma 3 here. And this is 1 comma 1. Right? So this is how you plot a line, for example this, onto a graph. Now, looking back into straight lines, let's go back from the start. A straight line is just a line, and we can define them by using 2 points. Let's call them A and B, all right? We have A and B. A perpendicular bisector of the line AB passes through the midpoint of AB and is perpendicular to the line AB. Now, what does all of this mean? It's giving us the definition of a perpendicular bisector. What is a midpoint? It is the middle point, which is why we call it midpoint. So, for example, here, let's say M. Then we are calling it midpoint because these two distances are the same, and hence this is right in the middle of A and B. So that is why we call it midpoint. What is a perpendicular bisector? Well, the bisect part tells us that it passes through the midpoint. What if is perpendicular? What is perpendicular? Perpendicular is when two lines meets at a right angle. So for example, if we have the straight line AB here, a perpendicular line could be something like this or like this, which we denote with the right angle sign. But a perpendicular bisector of a line AB not only is perpendicular to the line AB, but it also passes through the midpoint. So there's only one line which satisfies all of that. This must be a right angle, and this must pass through the midpoint, which is why this line is called the perpendicular bisector. This line. Alright, so we have that. So then, how do we find an equation of a perpendicular bisector? Let me erase all of this perpendicular bisector here. When we are, let's say, given the points of M, let's say x1 and y1 again. And what if we were given the gradient of AB? Let's say M. I mean, if you know the gradient of this line here, we can actually use, let's say this is a big M. Let's say if that's the gradient, then we can just plug that into the point intercept, right? Not the point intercept, the point gradient form, right? So we can have that is equal to y minus y1 is equal to m of that. But then we're given the gradient of AB. We are not given with what big M is. We want to learn how to, let's say, find the gradient of this when it's perpendicular. Well, what do we know? Well, we know that this change is, let's say this is change in x, then this must be a change in y, right? And I mean, let's say this is on a coordinate plane somewhere, then that will be small m is equal to the change of y over the change of x. And now we're given that this is perpendicular. How do we know? Like, what do we know about this? Well, it turns out that this line actually has a gradient of -1 over m, which means that this decreases. This is like going the opposite way, which is why we have the negative, in the different gradient of m. So let's say we have a gradient. Let's say this is a gradient of 1. Then if we substitute 1 into this, this is -1. So it is 1 and -1. But if it is steeper, let's say 2, then it's telling us that it will have -1/2, which means that it is shallower, but it is going down. So we can see that this is actually continuously forming a right angle because it is, since this increased, the steepness of this has decreased. It's continuously going to make a right angle. So that's why we have -1/m. So then this is perpendicular, and now we found the equation for this. And now we know that this is the equation of perpendicular bisector. And that's what we have here. A perpendicular, if the gradient of the line AB, which is the line AB here, is m, and the midpoint is x1 comma y1, the equation for the perpendicular bisector is y minus y1 is equal to negative of brackets 1/m brackets x minus x1. We can put a brackets here, or we can just leave the brackets out. So then we have that. What if we had 2 points which we knew equations for? Let's draw this neatly, and let's say they are not perpendicular. Let's say this is y equals, let's say 1/2 of x plus, let's say 1. And then let's say this is y equals, let's say -5/2 of x, let's say -2. What if we were told that these two equations and we wanted to find where these two meet? Well, we basically do that by solving a simultaneous equation of the two lines, which gives us the intersection of the two lines. What does that mean? We suppose that this is true and this is true at the same time. I mean, this is what that point stands for. If we plug in x1, like let's say this point is x1 comma y1, it must satisfy that y1 is equal to 1/2 of x1 plus 1, right? And it must also satisfy this equation because both is on this line as well. So y1 must equal to -5/2 x1 plus, minus 2. So these two must be the same. Y1 must be the same and x1 must be the same. So we suppose that both of these are true. And then we solve it. How do we solve this? Well, y1 is the same here, so we can actually equate these two. So 1/2 of x1 plus 1 plus 1, let me rewrite that, plus 1 is equal to -5/2 of x1 subtracted by 2. Which means that if we add 2 to both sides, then we have 3 is equal to 1/2 of x1. 1/2 of x1 plus 3 is equal to, this thing hasn't changed. So we have that. We subtract 1/2 of x to both sides here, which gives us -5/2 plus 1/2 of x1, which this thing is 3. Alright, if we divide -3 to both sides, we get x1 is equal to -1. Now, this is not the end of the story because, well, we need to find the y1 coordinates and we want to know where exactly this point is. Knowing x1 only right now, -1, doesn't mean that we know what y1 is yet. But we can plug this -1 value back into this equation here, up here, or the equation up here. Either of this equation works. So let's plug it into the top one, let's say. Then y1 is equal to 1/2, and x1 was -1 here, right? So -1, and then we plus 1, right? Then we get -1/2 plus 1 is equal to y1, which gives us 1/2. So now we can plug y1 in here, and now we know that these two lines meet at the point -1, 1/2. So this is what we mean by simultaneously solving these two. But we don't want to always use this variable y1 and x1 again and again. So that's why we just don't write them as y1 and x1, and we just solve them from y and x. Because we don't want to just write again and again and again. Just use the original variables and then just find what the variables are and then plug them in. So let's actually solve a few problems using these informations that we learned today. All right, if we have the point gradient form, right? So let's say we have the gradient is, let's say, 2, and the point that a straight line passes through is 1 comma, let's say, 3, then what will the equation of this line be? And write it in point gradient form. Point gradient. So what will this be? Well, we just use the formula y minus y1, which is 3, and then the gradient, which is 2, and then x minus x1, then that's the equation in the point gradient form. But what if it asks us to find it in, let's say, general form? General. I will just write general, but let's say it asks for it in general form. Then we will try to solve this in order to make this general. What do we know? We have y minus 3 is equal to 2x minus 2 because of expanding the brackets. And then we subtract y to both sides, or we can subtract 2x to both sides and then multiply -1. But if we want 2x to be positive, this 2 is already positive here. It's easier to subtract y here, although we would have to switch sides later. And then add 2 to both sides, which gives us 2x minus y is equal to -1. And we put it on the other side, 2x minus y is equal to -1. If they ask for this in gradient intercept form, so that we can find out what the y-intercept is. Gradient intercept intersect. Then we have this, right? We want to write it in the form y equals mx plus c. So let's add y to both sides, which gives us 2x equals to y minus 1. if we want y to be our main variable here, y is equal to 2x, and then we add 1 to both sides. So now this is the gradient intercept form. And just checking, the 2 hasn't changed from the gradient that we were given. So we can understand that our gradient is correct. And then the y-intercept we would give as 0, 1, or just simply 1. So that's how we would solve if we were given this information. So we applied all of this. If we were to graph, let's say we were to graph this information, and we were given let's say we were given a general form of 2x minus y is equal to -1, which is the line that we had in the start. Well, we want to find 2 points in order to graph it onto an xy coordinate, right? If x was 0, y would be 1, because if x is 0, then 0 minus y would be 1, -1. And then we multiply by -1 to both sides, which gives us y is equal to 1 when x is equal to 0. When x is equal to, so this will be our first coordinate. If x is equal to, let's say 1, then we would have 2 of, let's say 1 minus y is equal to -1. Let's simplify this first. 2 minus y is equal to -1. Adding 1 to both sides gives us 3 minus y is equal to 0. And y is therefore equal to 3. So it passes through the point 1, 3. You guys should use a ruler when you're plotting a straight line. But for me, I don't have a ruler, so I will try my best to draw. So let's say 0. This is 0 and this is 1. 1 and this is 3 up here. Then I can draw a straight line, something like that. And this will be our 2x minus y is equal to -1. So this is how you would plot a graph of that form. So if we were given, let's say, a line, let's say we were given a line of y equals 2x plus 1. And let's say we want to find a perpendicular bisector of the line, which passes through the midpoint, which let's say it is 1, 3. So then how will we find the perpendicular bisector to this line? Well, generally a line would have 2 points, but let's say it was just given this and we have the midpoint. We know the midpoint, so it definitely passes through that line, right? The perpendicular bisector. So y minus 3 is equal to m, the gradient, which we don't know yet, of x minus 1, right? Which is the point-intercept form. And then the gradient of the perpendicular bisector, as we learned, is -1 over the gradient, which is 2. So it's just -1 over 2. We can simplify this if we want to, for example, by -1, just expanding it like this. And then we can also add 3 to both sides after this, which will give us -1 half of x plus 7 over 2. Alright, so this is how we would use the midpoint formula and the gradient to find the, the equation for a perpendicular bisector. And then we have, solving a simultaneous equation of two lines. Let's say we had two lines, y equals, let's say 2x minus 3, and we had y equals, let's say, negative x, negative x, and let's say plus 3. So if we want to find the intersection of these two lines, we can not only plot it, but it's better for us to actually solve these simultaneous equation in case our graph is not accurate. And since y is the same, we use this and we say that these two are the same. And then we add x to both sides, 3x minus 3. And then this is 3. Add 3 to both sides gives us 6 is equal to 3x. And then x is actually equal to 2. And then we plug this in, let's say into this equation. Then 2 times 2 minus 3 is actually equal to y, which 4 minus 3 is equal to 1. So the coordinates of the intersection is 2, 1. So this is what we learned today, and I hope you enjoyed this live stream. And hopefully I will be back again to talk you through chapter 2, which is about sets and Venn diagrams.